Mr. Beyond here with your lesson for today. We're talking about electric force. So what is an electric force? Well, the definition for that is the attraction or the repulsion between two or more charged objects, okay? So whether or not things are being pushed together, they're being attracted to come together, or they're being pulled apart, right? Repulsion. Now, when we have these charged objects, there are three laws that help us determine whether or not attraction or repulsion is happening. And you may have heard some of these things used in colloquial terms before, but we can apply them here to charges. So our first law is similar charges repel. So if you have two positively charged objects or two negatively charged objects, they're going to repel. Now, if we have different charges, they attract. So if you have one positive, or you have a positively charged object and a negatively charged object, they're going to want to attract together. And, oh, sorry, I spelled that wrong. Different, sorry. And the last one here is neutral attracts charged. Okay, so even if you have something that's neutrally charged, it doesn't have a charge, if you bring something that is charged, they'll still attract. Okay, so this force, this push or pull, right? You may have felt this with magnets before when you're trying to pull apart magnets or something. What determines the strength of this charge? Well, we have three factors, right? And these three factors are the amount of charge, the size of the objects, and the distance between them, right? We can imagine, again, just like talking about with magnets, right? When they're touching each other and you're trying to pull them apart, it's very difficult to do that. But as you take it further apart, then there's no charge there, right? There's no force. But as you bring them closer, at a certain point, you start to feel that tug as they want to go together, right? So that is the attraction. If you get a little bit closer, it gets harder and harder to keep them apart until finally the magnets become too strong and they come together, right? So again, these are three of our factors. Now, when we want to charge an object, there's actually two different ways to do it. One of the ways is called conduction. And this is just a fancy way of saying you take your charged object and you directly touch it to your not charged objects. So conduction is direct contact. And so with this, if you have, say, a negatively charged rod and you touch it to, for example, something called an electroscope, which is basically just a neutral object that sits in a jar and will tell you if there is a charge somewhere. If this directly touches, so if we directly touch it, what ends up happening is some of these negative electrons will jump over into this neutral object, right? So some of those electrons will move over there, and this will become negatively charged. And then, as you can see here, because it's got two metal leaves, if it's negative on one side and negative on the other, you've got similar charges, and they'll spread out, right? Different charges. Sorry, similar charges repel. So this is one way. The second way is through induction. And induction is indirect. There's no actual touching of the two objects, right? You don't actually touch them. What happens is you put them very close together. And if you do that, again, put them very close together, but not quite touching. Remember, based off our rules here, the similar charges repel and the different charges attract. And in a neutral object, you will have an equal number of protons, electrons, right? The charges are balanced inside the object. But as you bring this negative rod closer to this neutral object, the electrons in the object will want to go away. And the positive electrons, or the positive protons, sorry, will want to get as close as possible to the rod. So what ends up happening is all of your protons kind of move up over here, up to the top side, whereas your electrons will temporarily run down here. So the top part of this new object here is positively charged, and the bottom part is negatively charged. The one thing with induction, right, is that this is going to be temporary, because as soon as I take this away, not too much longer afterwards, everything will just balance back out and it'll go back to being a neutral object. Okay, that is also one of the reasons why neutral objects attract charged objects, right? So same idea, right? We have a neutral object, and then we bring that charged object in, stuff will move around so that the neutral object is more charged on one side. And because it's more positively charged on the one side or negatively charged, it will then attract with the object that is charged by it. Okay, so I'm going to put up everything I said again into another set of those worksheets, so you will be able to go over them in case the videos are going a little bit too fast for you or something. You can reread exactly what I just said here, and then please do the one worksheet that's attached with those readings and submit that onto Teams. Okay, that's it for today. Take care.